Let's now look at a special right triangle that's a 30-degree, 60-degree, 90-degree triangle. If we start with an equilateral triangle like this one on the left, where each of the angles is 60 degrees and each of the sides is the same length, and we slice that triangle in half, the result is this 30, 60, 90 right triangle. And what I want to focus on today are the lengths of the sides. So, first of all, I want to make the shortest leg 1. And if that short leg is 1, that means the whole bottom of this triangle must have been 2. And that makes the hypotenuse of this triangle over here also 2. And what I want to do next is see if I can solve for that third side, the long leg. So we'll run these 3 sides through the Pythagorean theorem. And when we clean up this work, we learn that x is the square root of 3. And the square root of 3 is approximately 1.732. So that long leg here is more than 1.5, but less than 2. And what's interesting about this relationship is that the relationship of 1 and the square root of 3 and 2 is preserved no matter how large this triangle gets. For example, if we were to make the short leg instead of 1, say 7, then the long leg would be 7 the square root of 3, and the hypotenuse would be 14. That relationship is preserved no matter how big or small this triangle is. Okay, let's look at a few examples. In this first one, we know the short leg is 9, and we're looking for the long leg and the hypotenuse. Well, if the short leg is 9, the long leg must be 9 times the square root of 3, and the hypotenuse must be 18. It's that quick. Let's look at the next example down below. Here we're given the long leg, and we'll go back to the short leg and then get the hypotenuse. If the long leg is 12 the square root of 3, then the short leg must be just 12, and that would make the hypotenuse 24. Again, that's pretty quick. All right, our third example, these get a little more interesting. In this example, the long leg happens to be a whole number 12. To go back to the short leg, we simply divide by the square root of 3. So x will be 12 divided by the square root of 3. And if you clean that up to rationalize the denominator, the result is 4 the square root of 3. Now that we know the short leg, we can get the hypotenuse. If that's 4 the square root of 3, then the hypotenuse must be twice that, or 8 the square root of 3. All right, one final example. In this case, we're given the hypotenuse is 12. So like the previous example, I like to go back and get the short leg. So the short leg, if you go back to here, must be just 6. It's 12 divided by 2. And then the long leg is going to be the short leg. This long leg here will be the short leg times the square root of 3. So y will be 6 the square root of 3. And that's it.